Lauren first, and this is my co-guide, August, and we're both on the factory design team, but different factory design teams.
Yes.
What does that mean?
There's a facilities with HVAC and other processes, and then there's material flow and production line setup. So he's facilities and I'm production.
We're glad to meet you.
Sorry, I need my talking points.
On fait on the third one. Il y a quelque chose qui manque.
Is there anything much going on in this before? Last time I was there, it was just inventory.
Extrêmement content d'avoir laissé mon char.
Are you glad your car's not out there?
Ouais, mais on a une tempête de sable en même temps. Je peux-tu vous dire que je suis content d'avoir laissé mon auto à l'hôtel? Non, mais hein, c'est assez génial.
Dans un souterrain?
Au quatrième étage.
Stationnement fermé. Bravo les boys.
C'est qu'on commence la balade, on bouge en autobus. Là.
Okay. First is safety. So please stay with us. Don't hang around everywhere because this is a massive factory. You can get lost. Believe me, every time I come here, I need to ask someone where's my office. Okay. So just stick with us, and also you're allowed to take pictures and videos. So this is totally fine, but just don't use a physical Zoom or Capcom to take details. So that's not allowed. And also don't take our employees' face. So we're not allowed to show our face on the social media. I think that's pretty much for the safety side, right? Just stick with us and make sure you guys are safe. Because we're still doing production. You guys can see the actual production of the power wall and power pack. And in my last group, I saw some people getting real close, so that's not very safe. You can pretty much see if you are like doing beautiful way. You have to go very close.
And please hold all questions for the end. We will have experts at the end.
Bon, on a de la pluie aussi maintenant, en plus de la tempête de sable. Ça va faire un beau mélange de bois.
Keep a certain pace.
If we have time, you guys can ask some questions.
Oh yeah, while we're walking and or if we're waiting on another group, feel free to ask.
Le site est gigantesque. On n'oublie pas que ça a juste 15% de construit.
I've been here since March. The longest you'll probably hear is a year.
I design chemical process. I don't know if you guys.
Alors, on a une tempête de neige, une tempête de sable mélangée avec une tempête de pluie. On voit même les éclairs.
Factory will be running full renewable energy. That's one part. That's not my job. Someone else has it. Another job is all the end of life battery will be taken back for recycling. So I'm doing the recycling part.
Okay. What does that look like? What happens when they take it?
So we basically, to put it easy, we basically take all the valuable metals out and just put it back to the system. So closed system.
Moi, je vais essayer de rouler tout le long.
Never rain?
Yeah, never rains.
Never.
I never support
Never. Seldom?
Seldom.
Well, we gotta make it a few feet in, right? Yeah. What do you do?
I'm also on the factory design team, but I do production line, space allocation, and material flow analysis.
Yeah. Go on. What's that?
So when the layouts move very frequently, depending on what space or equipment is coming in, and constantly modifying layouts. Some of us on the team do 3D renderings, and I run those people, so I sort of just get a layout and put it in 3D as much as I can, or with the information that we know, and then material flow analysis with AGVs, pedestrian fraction and a small part of the plant. We don't look at.
On va bientôt rentrer dans l'usine
Exactly.
avec le bus pour faire le tour. C'est gigantesque.
With what? I know, yeah. Big shout out.
Et on est à l'intérieur maintenant. Ils sont en train de construire.
This is section D.
C'est la section D.
Panasonic, and we're going to enter section C, which is also Panasonic, and so section D. So most of this is all Panasonic except for section
On
F,
est à
which is where
l'intérieur.
all the current manufacturing processes are. So nothing is getting built in any of the sections except section A, which we will see at the end.
You don't have to worry about the rain at all.
Oh yeah, you guys are not. Yeah.
Sachant que les batteries maintenant, c'est mécanique. On va faire une petite pause, le temps de sortir. Ah ben. Bon, ben on recommence la tournée. Les brefs à l'intérieur. Juste une petite image comme ça, regardez dehors. C'est capoté.
So we're gonna show you how we actually make every sales here in the industry. Okay? And first I will introduce you this manual cell. We call it 170. So the manual cell has 5 key components. It has a vessel, a handle. In between the vessel and handle is a separator. The separator has defined the whole structure to allow these lines to pass through. Also, there's an electrolyte to facilitate and we also have the cell base with the structure and also for safety reasons. And on the top of it, you can see a cap. On the front of these caps, there's some safety device. The cell gets to the heart of it has an internal shock. The cell will Tesla cell, and you guys can see it, but just be careful, don't metal side, so you really see somebody shot it, so it burns their toes. Okay, but let's keep moving this direction. It's still lithium-ion chemistry. It's not empty.
No, that's real.
It's lightweight.
7,000.
It's surprising.
Voici une image de la nouvelle batterie que Tesla va construire ici pour mettre dans le modèle 3 probablement. On la voit, c'est super léger. Je l'ai dans les mains, j'en reviens pas. Et maintenant, c'est Hans qui l'a dans les mains.
I'm gonna stand behind you there.
La grosseur d'un 25 cents t'as dans les mains ou un 5 cents?
25 cents
La grosseur d'un 25 cents US. C'est ultra léger. 25 cents est quasiment aussi pesant. Picture in the same time. Nice. C'était carré. Moi, j'arrête pas de filmer depuis le début, là. J'arrête pas. Tant que je suis pas rendu à retourner dans l'autobus. Je peux prendre des photos en même temps, fait que...
not right.
Alors, on marche à l'intérieur de l'usine de batterie Gigafactory. C'est capotant, incroyable, réaliste.
Wait, where are the speakers?
He has it. Since he works in the back, so it projects forward. But the mic is Hunter's company has one.
I can't keep doing
Fait une petite pause de quelques secondes. OK, on est reparti. Il fallait laisser de la place à l'autre groupe. It's a shower. C'est une douche.
What you're seeing here is the positive side of the electrode making process, but I will generally talk about both sides of the electrodes being made. 30,000 cells worth of electrically active minerals mixed with the solvents.
You are a star! You are a star!
Speak slowly.
Sorry, I have to read off this paper. I'm not prepared.
We speak French usually, that's the problem. We should rewatch the video after.
30,000 cells worth of electrically active minerals mixed with the solvents, allowing these minerals to be coated on a charge carrying foil. The goal of this mix thoroughly and quickly to ensure a highly homogeneous mixture of active minerals throughout the cell at a rapid rate of production. We use a synthetic solvent capable of baking off at a lower temperature while interacting safely with the highly active minerals. We even designed a new way to recapture it after it's baked off and refine it back to its pure product on site in a process similar to making whiskey.
You're doing a good job.
Yeah.
Oh, there's a floor.
We move it to see it on slow motion after that.
Oh really? Was I talking that fast?
No, it's just because our first language is French. Sometimes it's harder to understand. Now after that, we go back to home and we're gonna watch the video. It's okay, that's what she said. That's nice.
I apologize. I'll try and slow down.
No, it's don't change anything.
Is that shower for like if you get like hurt or something, you go like wash your hair?
It could be. I am really not familiar with the Panasonic side. I'm just getting these notes.
Fait qu'elle a dit que c'était quoi ici?
On aurait une fois fait ça comme ça.
Ils ont même de l'eau chaude pour se nettoyer. Ils ont même un chauffe-eau.
Ça fait grosseur du chauffe-eau et assez pour laver une famille au complet. Fait que je suis pas capable de vous dire c'est quoi ici. Il va falloir réécouter les vidéos tranquillement pour comprendre ce qu'elle dit.
Tu filmais le...
Ouais. Pour ça, as-tu compris qu'est-ce qu'elle a dit que c'était?
Ben, c'est là qu'ils font comme un mix pour aller dans la batterie.
Dans ça?
Ouais, je pense que c'est ça.
Ah ouais?
Ça, mais ouais, je vais réécouter ta vidéo aussi.
OK, on fait une petite pause, le temps de passer la prochaine. OK, on continue, on vient de changer de pièce. Désolé si ça bouge un peu, c'est pas toujours facile. On vient de prendre en photo le speech de la fille.
Welcome everybody. My name is Ryan Melser. This is my colleague Jacob Miller here. We're members of the factory design team. So we're responsible for the design and optimization of the thermal, chemical, and mechanical systems both here in the factory and in our utility yard. So you just walked through the cathode mixing room, where you might have heard that whether anode or cathode, our active material is perceived as a dry powder in these large sacks. We need to apply this active material to a metal substrate. However, we can't just apply this powder to a substrate on its own. So in this mixing room, we add a solvent to this powder material to turn it into a liquid. And then this liquid solid mixture is pumped from our big mixing booth here all the way down to the far side of this room. The last chamber on the ground floor here is our coating booth. So we have a large roll of this metal substrate that we unroll and apply in a similar fashion to a printing press. This liquid slurry is applied to the top in a die fashion. We now have this wet slurry on top of this metal foil substrate coming towards us in the oven chambers. Every one of these chambers has an airflow in and an airflow out. That air is at a very prescribed flow rate and temperature in order to control the rate of evaporation of that solvent. By the time we get to the last chamber here, we now have a dry, solid, active material that is stuck to this metal substrate. We take this substrate and we turn straight up vertical, and we go to our second coating booth here, and what was the bottom is now the top layer, and we coat that new top layer with that same slurry. And in a similar fashion, we pass it back down the top row of the oven to dry it again. So when we get to the top row at the end there, we now have this metal substrate with solid active material stuck to both sides of it. As I mentioned, there's airflow in and out to every one of these chambers, and as the air goes in, it is picking up the solvent as it evaporates out of the liquid phase. Instead of just venting this to the atmosphere, we collect all that air together into one big duct, which you see at the very end there, going into our second floor through that wall. This large airflow now containing a lot of solvent in it, we pass through a solvent recovery system, where we actually scrub the solvent out of the air to clean the air, and then the air is passed back in that top duct back into this oven chamber. So the air is operating in a closed loop fashion and never leaves the building. The solvent that we just pulled into the liquid phase, we pump out to our utility yard, where we treat and clean the solvent, and then that solvent itself is passed back into this cathode mixing room where the solvent again is reused. So both the airflow and the solvent flow are in closed loops. So on a net basis, the only material that leaves this room is the active material and the substrate. So this very large oven here used to be the largest power consumer of any piece of equipment in the whole factory. But over the past year, Tesla and Panasonic engineers have worked together to redesign how this oven operates and also how that solvent recovery system operates. And in doing so, we've been able to cut the power consumption of the system by over 80%.
Wow. Good job.
Thanks. So this is the first oven of the first line in the first Gigafactory. So in making this big investment up front, now all those savings get propagated forward for all future ovens. So right here will be the second cathode oven, relatively soon. And where you drove through in section D and get out of the bus, there's a whole nother row of ovens and then other sections of the building and going forward.
Wow.
So this is a big method in how we reduce the power consumption here and become net energy neutral. And reductions in load like this in these major pieces of equipment are far more a cost-effective way to get to being self-sustaining on a power basis than by trying to generate renewable energy on site. So this is the low-hanging fruit we go after first, reducing internal load, and then making up the rest with on-site generation. Any questions? There's no natural gas pipe to this facility at all. All heating anywhere is electric.
Good.
We're talking for the oven, how many watts, kilowatts, megawatts?
Very large. We won't give the actual number, but it's a very large reduction. You just see the size of the oven. It's in the megawatt range.
Good.
Well, thank you.
Thank you to you.
How fast will it cook a pizza?
What kind of temperature?
And the electricity is generated only by solar panels or through the grid?
Eventually, it'll only be by on-site generation.
Right now it's from the grid.
But right now, these aren't operating.
Okay.
So these are still in the commissioning phase.
And when they're going to be operated, the solar panels are going to be on the roof
And other types of
and
generation.
windmills and stuff.
Yep, that's the end game.
Thank you. On va prendre une petite pause. Alors, on continue dans le corridor pour la visite. C'est tellement neuf que ça sent la peinture neuve. C'est la première fois que je vais dans une usine qui sent la peinture neuve. C'est plus que irréaliste. Alors, on est rendu dans une pièce que je peux pas vous dire encore c'est quoi. On va savoir bientôt. On va savoir bientôt c'est quoi. C'est quelqu'un qui va nous expliquer. Il y a des choses qui sont opérationnelles dans l'usine déjà. Il y a déjà des power packs qui sont fabriqués. Certaines parties ne sont pas encore opérationnelles. On s'entend que c'est une usine flambant neuve. Ça sent encore la peinture fraîche à des places. Évidemment, il y a certaines choses qui ont été cachées. C'est tout à fait normal pour les secrets de...
This active material isn't a completely flat layer because of the areas where the solvent molecules used to be. So we need to send the foil through massive hydraulic pressing rollers to flatten the electrode foils to the right thickness. The thickness of a foil after being pressed is the same as that of a thin piece of human hair.
Wow.
60 to 80 microns. There's an expert around here who will tell you more, but there's a group there, so I'm just going to mosey slowly on over.
Les lignes blanches que vous voyez par terre, c'est des lignes autoconducteurs. Ça veut dire que c'est des chariots qui vont pouvoir se promener sur l'usine sans avoir de conducteur. Ils vont avoir des destinations, ils vont suivre les lignes au plancher qui contiennent normalement du magnétisme. Alors, ces lignes-là vont permettre à des chariots, élévateurs ou autres de se promener sans avoir de conducteur.
My name is Matt. I'm an engineer with the factory design team here at the Gigafactory.
You're a lucky guy.
I'm one of the engineers that coordinates the install for all this equipment.
And we are going to tell you a little bit more about cathode press over here. So you guys just came from the coat and dry ovens, which is where we've evaporated at that point all of the solvent that was used in the mixing process to apply the active material to the foil. So now we're left with just that active material and the aluminum foil and a bunch of air from where the solvent used to be.
When you receive it, is it hot, cold, room temperature? Room temperature.
It's room temp. We'll show you the storage system right here. Okay, yeah. We are basically trying to get rid of this air. We're compressing the material down to the desired thickness. What we're after is, to give you a sense, in order of magnitude, it's roughly the diameter of a human hair. Okay? So we're using these big, huge 4.5-ton rollers in there, which unfortunately are covered up, but we're trying to get that level of precision out of this really heavy piece of equipment, which is pretty challenging in itself. Really, we're after a porosity in the material after we're done with the pressing system. Really what we're trying to do is to get the right material properties at that point. We're trying to optimize the flow of lithium coming into and out of the electrode itself. If we compress this too much, the electrode or the electrons actually can't flow freely across the electrode. You're creating internal resistances within the cell, which is obviously undesirable. If you don't compress the material enough, you end up missing out on energy density. What we're trying to do is pack as much active material as we can into each cell in order to make the highest performance cell that we possibly can. So that's the game here. Brian will tell you a little bit more about how this actually happens.
Yeah, we walk you guys through the material flow. So as Matt mentioned, from coat and dry, you have a coil that's had active material applied to it, and it actually gets fed into this buffer rack system. So feel free to come in and take a look.
Donc ici, ce qu'on voit, les machines, c'est des machines de presse qui vont presser, si j'ai bien compris, le matériel qui va entrer dans la batterie. Il faut qu'il soit pressé à une certaine pression pour en avoir le plus maximum dans la batterie. Donc on ne voit pas les presses, mais ils sont derrière les toiles noires.
This system itself will support, or does support, all of first floor and third floor processes. Basically, each bay you see here will store one coil. Down the center aisle,
Ça, c'est un endroit d'entreposage.
it'll bring it down here to an automated
C'est giga gros.
So that robot essentially will receive the coil, and it'll follow this track you see on the floor. Magnetic strip right now, it's just coming to the back. It'll have this epoxy finish. That AGV was going to bring that coil into the room, into the press machine itself. It'll lift it onto these spindles here. And basically what this component's going to do is going to unwind that coil. And it's going to feed the foil into the roller press, and what's covered up here. Your two large hydraulic presses, as Matt mentioned, about 4.5 tons, top and bottom. That's basically, those are calibrated to get your micron level tolerances in the film.
Is it covered because it's secret or secret factory?
It's proprietary information to Panasonic, so kind of their secret sauce, as well as you have to keep it clean because it is a sensitive process.
Good.
That foil feeds through the roller press back into what's essentially a rewinder, so similar to what you have up there, but it's going to wind the coil back up. It'll load back onto an AGV. AGV takes it into the buffer rack or the storage system, and that'll...
But now it will be way thinner.
It'll be thinner, yeah. It's about half, basically the thickness is about half from where it just came from. That'll get fed to downstream processes through the buffer system.
Does it degrade with time or anything like that, or environmentally?
I'm sorry?
Does it degrade environmentally? Is there a time limit or something like that?
No, there's no queue times or anything like that for this part of the process, so not really sensitive to time in that sense. And the room itself is environmentally controlled to help eliminate that from happening. So all your temperature, your humidity, your environmental factors. So the process is mostly automated, but you will have operators that are kind of monitoring the equipment itself. Some of the stuff that's covered up on the front end here is kind of the metrology, what's taking the measurement of the film. So they'll measure before and after, and basically they're watching on each coil that you have that target thickness that you want, and they're kind of doing the fine-tuning adjustments for that.
Since there were other plants manufacturing batteries before you opened this year, how much improvement would you say Tesla brought to the process?
It's hard to quantify that. There's individual components where we've either made them more dense in the sense that we've fit more equipment into a smaller space, or we've increased the throughput. And a lot of that is in collaboration with Panasonic.
So, because Panasonic had already plants where they were manufacturing those batteries before you opened here.
Essentially, yeah, they've been one of the suppliers for Tesla for a long time.
So you guys probably improved the manufacturing way of producing the batteries, but not the battery itself?
All aspects of it. So we have an engineering team that focuses solely on the battery itself, so materials, the size, the density of the battery, things like that.
Basically, you're saying you're not only producing batteries the way it's produced right now, but you're also developing a better battery.
Higher energy density, longer life, everything you can think of. Tesla has some sort of engineering presence with Panasonic there.
How many milliamp hour has the new battery?
Oh, I don't know that off the top of my head.
So on these great big drums,
the coils themselves?
how many batteries does that create?
So basically, this
cut up, is it?
yeah. So this big roll essentially is about 1,200 cells, give or take, and that in downstream processes will get cut into smaller strips, and then that'll get combined with your anode material and wound up into basically what you see as the cell itself. I don't have one with me, but it's like a larger. Yeah, it's like a big
about 1200
AA battery. Yeah.
Graphene. How long does it take to go spool off there and over there? Is it seconds or?
It's about a meter a second. I don't know the exact length of the film, but it's pretty quick. It's on the order of minutes, so it's not too long. Yeah.
Just another question. Since we're producing batteries the way we think it should be done today, and we know that in the world right now there's a lot of research on new ways of stocking energy, like graphene batteries and stuff like that. Would you say that this manufacturer would be able to adjust to those new technologies as they appear in the market?
Obviously, with the scale of the equipment, it's a little difficult as you introduce new materials and things like that. But to a certain extent, the machinery itself, the manufacturing process itself, stays the same. So there are things you can do. The section we're in right now, sections B and C, the design of this area is actually quite a bit different for the new construction that you walk through. So those areas will have same materials, but they'll increase the density of the processing, the manufacturing capability of it, the throughput.
And since you're working in that space, I'm not, and I'm always, as an external observer of this bet, I would say, because I call it a bet somewhere, because we're building a huge plant to build batteries the way it's been produced like 10, 15 years now.
Right.
Maybe improving the manufacturing way and stuff like that, but it's still the same components that we were using 15 years ago. And because of the world that is shifting to energy stockage and batteries and the importance of batteries in all kind of aspects in the future world, I think it's a big bet, because maybe in 5 years we'll come up with a new way of producing batteries. Will be far more.
It's a free market, you can do it.
Sorry?
It's a free market, you can do it.
Yeah, the beauty of this is we work so closely with Panasonic and other suppliers that as that technology develops and becomes more manufacturable, that we're right on the forefront of being able to implement that on a larger scale.
Okay.
But 5 years is a long time, so we obviously have a lot of cars to make in that time. So we need to take basically the best technology we have currently available and try to produce that as quickly as possible for as low a price as we can.
Yeah, that's a good to be present.
Yeah.
But the focus is on one chemistry to mass produce lots and lots of batteries for Model 3 mass production.
Yes.
Basically, right now.
Yeah.
That could be tuned down the road, but that's the target.
Yeah.
You got to stay focused on that.
Yeah, so there's Model 3 production is key. Obviously, we have Tesla Energy as well with the super packs and the power walls and things like that.
Right.
A little bit different chemistry between the two, but yeah, essentially the same process.
Okay.
Thank you.
Thank you.
Would it be possible to receive your lithium-based material already a bit thinner before you compress it here?
Basically, raw materials already come in a powder form. We're compressing it
you stock it with the lithium base, the raw material with the lithium, and then you laminate it here, right?
We're basically just compressing it, so the film properties change as you change the thickness of it. So there's not much upstream we could do to eliminate this process per se. This basically just gets it to where we have that target thickness, so we can increase the energy density and compete with it.
OK, on continue.
Yeah, exactly.
Ouais, vous avez un exemple ici des chariots qui vont voyager sur les lignes au plancher. C'est le genre de chariots autoguidés qui vont suivre cette ligne-là. Présentement, il y a un tape par-dessus la ligne pour la protéger, mais c'est ce qui va